Chemistry is the study of matter. What do you know about matter?
Everything's matter except electricity.
What is electricity and considered? It's the flow of electrons. Electrons are a substance. You're into something. Energy is very different from matter.
Because it can change?
Matter can change. More or less. So it can expand and shrink depending on the
Can you lose matter?
I can lose matter, but can I destroy matter? It changes form. So if you break off a piece of your pencil, you still have a pencil, but that pencil is more just or maybe in the sharpener, for example. Matter is defined as anything that has mass and takes up space. What is mass? We say that everything that is matter has mass. What do we say? If we say that matter is stuff, what is the stuff?
Gas, liquid, or solid?
Okay, and those gases, liquids, and solids are space of
Matter.
matter, which are made up of.
Electrons.
Oh, I'm looking for a keyword.
Particles.
So it all comes back to particle theory. So if I have a sample of something, inside that sample are small parts that are represented by circles. And each one of those circles is called a particle. Depending on the movement and motion of that particle defines whether it's a solid, a liquid, or a gas. What can we say that things take up space?
It has a weight. It has a weight.
What is weight related to that?
Gravity.
Yes, it is. Whatever planet you're on, gravity is the pull to the center of that object. So, for example, if you go up to the moon, what happens to your weight?
You weigh less.
Much less because there's
Less movement.
gravity. So the less pull there is, the less you weigh. So weight is due to gravity, but it's also due to your mass. If you have two people and one person is made up of more stuff than the other person, which one is going to have more weight?
What's the question, say?
If you have two people and one person is made up of more stuff than the other person, who's going to weigh?
Well, more stuff.
The more particles you have, the more the force of gravity can pull you down to the center of the planet. Mass doesn't change. If I go to the moon, my mass is the same, but my weight changes. Weight and mass are two things that are very, very often confused because we talk about them as being synonymous. Because of this idea that weight is related to mass. But space is different. What if I use the word volume to clarify what kind of space I'm talking about? I'm not talking about space, the final frontier. We're talking about space as in what one-dimensional volume that object occupies is coffee mug occupies way more space than the cell phone. That changes based on its temperature. What generally happens to objects when we increase the temperature? So you recall quite a bit from the last unit, which is really good to see. What I want to do is look at reviewing our compound formation. It's pretty hard to launch into balancing chemical reactions and predicting chemical reactions if you don't know about the chemical formulas and how to use them. So first of all, the answers to the pre-assessment, potassium sulfide is K2S, and it is an ionic compound. Zinc iodide is ZnI2. It is an ionic compound. Sulfur dioxide is SO2, molecular compound. Dinitrogen hexoxide, N2O6, molecular compound. Calcium chloride, CaCl2, it is ionic. Calcium chloride, CaCl2, ionic compound. We have sodium chloride, NaN, which is also an ionic compound. Aluminum sulfide is Al2S3, ionic compound. Carbon tetrachloride, CCl4, molecular compound. Judging by just walking around and seeing this, a lot of people have forgotten how to do formulas of ionic compounds. Many people, once they knew what the prefixes were able to do molecular compounds very easily, and classification was not something that was easily recalled. When I was talking to the guys, we got into the discussion of metals and non-metals. Do you remember where those are on the periodic table?
On the left side,
Is?
metals.
Okay. Left side of what? The left side of what is where you find the metals. Okay. We have this staircase line here. It starts between boron and aluminum, and then it goes down the periodic table. That separates the metals from the non-metals, which are on the other side. I did not put the staircase into your goldenrod periodic table, so I would highly recommend that you take a moment and add it in. You start in between aluminum and boron, then in between aluminum and silicon, then between germanium and silicon, down between germanium and arsenic, above antimony, below arsenic, in between antimony and tellurium, then between tellurium and polonium, then between polonium and astatine. We would predict that the line would continue between astatine and tennessine, and then between tennessine and ogacidine. Not sure yet. The challenge with working with these new substances here is they last for a very, very small fraction of time. We're talking milliseconds before some of these do come out. So it's really hard to determine what the properties can be. A lot of what we are seeing on the table for those last four predictions of what it could be looks like. It is entirely possible that before you graduate, you'll have to change this setup in order to grow. We're always pushing our knowledge in the chemistry area. Okay, balancing. How did this go? How many people know clue? Don't remember this at all. Okay, that's right. Anybody kind of sort of get a hint of what this is about?
It's about science.
Vague memories. Anybody able to do this right off the bat?
I remember what to do that. I'm just going to.
Oh, okay. So you're doing it by rote, you don't really have an idea of how you're doing it?
Pretty much, yeah. Well, I remember that I'm supposed to have the exact same amount on each side.
Yes. But really long.
Oh, yeah, that makes more sense. Never mind.
We want to make sure that as we're doing this, we understand why we're doing what we're doing, because there is a reason. So, the first inclusion is actually already balanced, if there's the same number of phosphorus and chlorine atoms on each side. B is 16:3:8 in front of each compound. C, the ratio is 3:1:3. And then finally, the last one, this is a combustion equation. Combustion equations are always going to push you a little bit more with the balancing. This is a 2.746. Just to remind you, on Edmodo, we have a group classroom. Physical Science 20. This playlist will be changing. This was the heat unit playlist. There will be a chemistry unit playlist up by the end of the day. And if you go to that playlist, it will have the lectures, and it will also have other videos that you might find useful if you need more examples. Also, for this unit, there is a folder, Reviewing Science 10 Chemistry. And if you go in there, all the stuff that we're going to be reviewing over the next couple of days has supporting drills and simulations here. So for example, there's an interactive balancing here. There are 3 videos going through how to balance. So if you're having some troubles, remember to look there for some extra support, or to come see me during RTI or after school. I will not be available Thursday after school this week because I'm going down to Regina right after school. Okay. One of the nice things about teaching chemistry is that there's far more chemistry comics than there are appropriate comics for the heat unit in Physical Science 20.
How is it possible that only 92 elements are found in the natural world, but there are millions of different types of substances? The secret is that atoms combine into compounds, which provide the great variety of chemical structures that make up the different substances we find in the universe. Compounds are made up of combinations of atoms.
Let's see if they'll work today.
When atoms bump into each other, the electric charges of the nucleus and the electrons of one are felt by the other. This is the electromagnetic force that binds atoms together. The way they do that is by sharing or donating the electrons in their outer shells. There is a natural tendency for atoms to seek equilibrium and fill their shells with electrons, and they do this by combining with other atoms. The more full the outer shell of the atom, the greater its stability. An ionic compound is formed when an electron from one atom is lost to another, and the 2 ions form an ionic bond. They are held together by their opposite electrical charges, but they remain as individual ions. A molecular compound, on the other hand, forms when atoms share some of their electrons in a covalent bond. Oxygen, for example, has 8 electrons. In order to become stable and have a complete outer shell, it needs another 2 electrons. Hydrogen has only 1 electron, but when 2 hydrogen atoms combine with an oxygen atom, the 3 atoms in the molecule will share electrons in order to fill their outer shells. 2 atoms of hydrogen and 1 of oxygen is a molecule of water, H2O, one of the most common and stable substances on our planet. In some instances, 2 atoms of the same element combine. Oxygen in the atmosphere exists as a molecule of 2 oxygen atoms, O2. Hydrogen is often found as a molecule of 2 hydrogen atoms, H2. When atoms combine, the resulting molecules can take on a character much different from their constituent elements. Hydrogen is highly explosive, and oxygen burns. But put together, they create water, which puts out fire. One of the marvels of modern chemistry is that scientists have even been able to create new molecular structures, such as plastic. Chemists have learned to manipulate the molecular structures of petroleum to create products with the exact characteristics they want. Not only have chemists learned to analyze the properties of molecules, but they have also developed their own way to describe them. Every chemist knows that H2 means that the molecule has 2 hydrogen atoms. The formula for butane, a highly flammable gas, is written C4H10. The molecule in this compound is made up of 4 carbon atoms and 10 hydrogen atoms. These types of formulas are an international shorthand that can be understood by everyone once they know the symbols for the elements.
I'm going to give you notes for this, handout for this. These are going to be your notes for the review section. When we look at compounds are groups. These groups are made up of at least 1 of the 118 elements on the periodic table. How they're joined together depends on what happens to the electrons in the last layer of their model. If those electrons are shared, they form a molecular compound. But if those electrons are transferred, they form an ionic compound. When we talk about chemical formulas, we're using the symbols in order to identify which of these elements are present in the formula. And then there's also subscript numbers down on the right-hand side, which tell you how many appear in that structure's formula. We classify depending on whether electrons are shared or whether they are transferred. The first category of compounds that we're going to review are called ionic compounds. As their name suggests, ionic compounds are made up of ions. And ions are formed when something that is a positive charge attracts something with a negative charge. We give fancy names to things that have positive charges or negative charges. There's something that is positively charged, say that is a cation. A T in the word cation reminds me that this is a positive charge. An anion is a negatively charged ion. Take a look at your periodic table. You'll see that your center of the periodic table has a legend. It identifies what all of those numbers mean in your periodic table. So the ion charges.
Yeah, why is it plus 2, 1?
Tends with things, but it uses electrons. How does it help to tell how many protons there are inside?
Positive number, like 29.
Okay, so the atomic number tells you the number of protons. So an atom of copper has how many protons?
Pardon?
How many protons does copper have? 29. Now, if it is an atom, it must have 29 electrons. Because by definition, an atom is magically neutral. Positive and negative must equal 0. However, copper can be 1 positive, or copper can be 2 positive. The number of protons cannot change.
Mrs. Johannesson, telephone line 1. Mrs. Johannesson, line 1.
The number of protons cannot change because the number of protons identifies that substance. But if you make that 30 protons, it's no longer copper. That is not the very opposite. Exactly. But the number of electrons can change. If it is 1 positive, it is because this has lost 1 electron to something else. 29 positive plus 28 negative gives you 1 positive. Or, if there's lots of energy involved, you can knock off 2 electrons. If you knock off 2 electrons, well, 29 positive plus 27 negative means that you have a 2 positive charge.
Would there be a special name for that?
It's really, really fancy. That would be called copper 1.
Oh.
And this would be called copper 2.
I can handle that.
There is actually an older style of naming called the classical system, and you have to use the Latin name for copper in order to name it. That is not used very commonly anymore because we don't study Latin in school anymore. Unless we have in the States. It's just Latin as we have to. So, here we have a picture of the sodium atom. How many protons are in the sodium atom? You can look it up on the periodic table. Okay, when I ask you the number of protons, I want you to look up the atomic number.
11.
Yes, for that substance. We have 11 protons, which are positively charged. If it is an atom, it is electrically neutral. That means how many electrons does it have?
10.
Sure. To be electrically neutral, you can have 10 electrons.
So does each ring have an even amount of electrons on it?
No.
Those 2 8
Only we're going to hear 4 models.
Yeah, that's what I mean.
So 7 is right.
So the ring can have a
You can have 2 electrons in your first ring, 8 electrons in the second ring, and up to 8 electrons in the third ring. But in sodium's case, only 1 electron is in the third ring because there's only 11 electrons. So in an atom, the number of electrons is always equal to the number of protons, because by definition, an atom must be neutral. It has to have the same number of electrons and protons. This structure of sodium is incredibly unstable. It's incredibly unstable because there's only 1 electron in that mass energy level by itself. So it is very, very easy for another substance to steal that electron. Think about analogy of a farm. Okay, you're in the center of that atom, and you've got a leather sheep around you. There's a coyote coming after that sheep. And after the sheep, which one's probably going to take it? Try this one. It's the same thing with atoms. If you have something that's farther away from the pull of the nucleus, it's going to be easier for that electron to be stolen. The number of protons in the sodium ion is still 11. However, if 1 electron is taken away, we have 10 electrons left over, which means we have a charge of 1 positive. If you look at number 11 on your periodic table, check the right-hand corner.
Plus 1. 1 plus, actually.
1 plus. I'm very, very picky about if the plus goes before or after the number.
Why?
Why? Because in chemistry, 1 positive is a charge. Positive 1 is something called an oxidation number, which is something that you will be taught if you go on into chemistry 30. And I'm a stickler in physical science 20 because I don't want you to get confused in chemistry 30.
Oxidation is on metal cation losing electrons.
An oxidation number is a bookkeeping system for looking at gain and loss of electrons. It's something that we assign to numbers. Is not necessarily a true representation of electron loss. It depends on what the substance is and who it's decided. Some things are better stewards of electrons than other things. If you put next to an electron, you could probably lose an electron. Take a look, just scan through the periodic table. Remember where the separation is for metals versus non-metals. Take a look at your metals. Do you notice anything about the charges?
Positive.
Versus the non-metal side.
What is the next thing?
Yes. Why is there some without an ion charge?
Or is there some?
Without an ion charge.
Do you remember what that last column is?
Oh, it's
It has a special name out there on the computer.
it's already gas.
It is something gases. I call it noble
Ah,
gases.
that's nice. That's it.
Do you remember from science of the characteristics of the noble gases are?
So what about, is there such thing as noble metals then? Because there's some metals without an ion charge.
Well, let's talk about noble gases first. Do you remember what their characteristics of noble gases?
Very reactive.
Unreactive.
Damn.
The reactive ones are group 1, which are alkaline metals, and group 7, which are the halogens. Those are the two most reactive families. So the noble gases are generally unreactive. They don't give up their electrons very easily because their electron levels are full. That's why they have no charges. So you're looking at the ones down at the bottom here. Okay. On my periodic table, it's a little bit easier to see. Do you see how on my periodic table substances are colored green? So 93 and above are all green because they're synthetic, which means what? They're created in the lab. They don't exist in nature. They exist for pretty short periods of time. So we are still in the process of understanding what happens to their electrons. We don't really know if they are acting like a typical metal and will lose their electrons to something because they decay and break apart so fast. So that's why 93 and above tends not to have a charge. Another one that's curious is C and SI, number 6 and number 14. What happens? Because they like to share. They don't like to
Boron.
Boron needs to share. And then give up a little bit different. We looked a little bit more about electron behavior in the Chem 30 material science unit. I'm hit, I've lost an electron. Are you sure I'm positive? One of the most challenging things for beginning chemistry students to keep in mind is that the loss of an electron means that something becomes positive. How is that possible? Something loses an electron becomes positive.
Oh, because if you have 0 pairs and you lose a negative, it'll be a positive.
Okay, so when you lose an electron, you're losing a negative charge. You have to remember that an atom has 2 charged particles inside it. Not only does it have negative charges, it also has positive charges. So, when something loses an electron, the number of protons is not changing. So if you take away one negative charge, then you have less negative charges compared to positive charges, and your object is going to have a positive charge. Conversely, if you gain an electron, the charge will go up. Alright, we'll continue our review tomorrow. If there's anything that I can help you with, please let me know.